Okay, we'll make a start. Well, welcome everybody to this evening's webinar. My name is John Jordan and I'm the chairperson of Engineers Ireland Northern Region. This event tonight is a joint event with our colleagues in the Institute of Civil Engineers Northern Ireland. I'm very pleased to see such a high attendance for our first CPD event of this 2025-26 season. The presentation tonight describes the various procedures and challenges involved in the management of earthwork and drainage assets on the Translink Northern Ireland Railway network, and is jointly delivered by representatives from Translink and their consultant Amey. Before we get underway and I introduce our speakers, I have a few announcements of other upcoming events for our members. Okay, so on the 9th of October, we have BIM for flooding. So discover how to transform asset data into actionable insights for flood risk management, and that's given by Paul Campbell from Autodesk. On the 13th of October, we have a presentation from Professor Jerry Murphy of the UCC, and he's going to outline a series of decarbonisation and pathways for agriculture, industry and transport, which employ circular economy systems that integrate offshore wind, electrolyzers, hydrogen, Power-to-X and biorefineries. On the 14th of October, hosted by Zoom as part of the UK Women in Tech Week, this illuminating session is designed to cut through the AI hype and provide you with practical and actionable insights into artificial intelligence technologies. And finally, on the 4th of November, with the venue to be confirmed at this fully in-person meeting, Engineers Ireland Director General Damien Owens will present changes to the Institute's bylaws. It's open to all members and will give you an opportunity to ask any questions you may have. At the meeting, Damien will explain the changes agreed by Council prior to holding of a special general meeting for final approval by the membership in November. You can register for all these events via the Engineers Ireland website. Over to Richard Nicholl now for the ICE notices.
Good evening. Thank you, John. I'm Richard Nicholl. I'm standing in for our chair, Wendy Blundell. And thank you to Ronan Gormley for the slide, just setting out upcoming ICE Northern Ireland events. So 2 days' time, we have an attribute discussion. That's for iEng and CEng preparation. And this attribute will cover management, leadership and commercial ability, hosted kindly by Amey. 13th of October, then we have a signature paper by Philip Brown and Louise Sterrett on the Belfast Transport Hub. And that's jointly with Chartered Institute of Highways. Then moving on, 20th of October, there is a half-day dynamic risk assessment session. It's free to be held at Nuts Corner, and the speaker is Bernard Granger. And then finally, just to point to 10th of November, again, reopening of the Foynes to Limerick railway line, and that's a joint evening meeting with the Institution of Structural Engineers. So there's just 4 upcoming events, and they can be accessed through the Institution of Civil Engineers website, and free to non-members. Non-members are also welcome. So thank you, John.
Thanks, Richard. Okay, so to introduce tonight's topic, the Translink Railway network operates on and within a significant number of embankments and soil rock cuttings of varying geology and profile that were constructed in the late 1800s. This presentation will include a discussion on the modern examination and maintenance regimes carried out by Translink to maintain this aging earthwork asset base in the face of a changing climate. We'll also provide some commentary on emergency intervention and planned renewal of earthworks assets in the challenging railway environment. We're delighted to have 3 speakers this evening. We have David Harrigan from Translink. David is a civil engineer who graduated from University of Ulster in 2007, and for the past 4 years has been the earthworks manager with Translink, responsible for management of their significant earthworks and drainage portfolio. Ruth Kelly from Amey is a chartered geotechnical engineer who graduated from Queen's with an MEng in civil engineering in 2012 and a PhD in geotechnical engineering in 2018. She currently carries out the role of the Earthworks examining engineer and on-call engineer on NIR's earthworks assets, and has experience in detailed design of earthworks, deep and shallow foundations, rock net systems and retaining structures. Finally, Matthew Thompson of Amey Matthew's a geotechnical engineer who graduated from Queen's with a BE in Aerospace Engineering in 2012 and an MSc in Environmental Engineering in 2017. And he carries out the role of an Earthworks examiner on NIR's Earthworks assets. Matthew has 10 years' experience in design of geotechnical assets, including foundations, earthworks, retaining measures, rock net systems, and flood defence schemes. I'd ask if you have any questions that, as you go along, that you post them in the Q&A. The button's available at the bottom of the screen, and Richard will kindly host the Q&A at the end of the session with our panel. Over to you, David, Ruth, and Matthew.
Hi folks, I'll give a short introduction to the Earthworks and Drainage on Northern Ireland Railways network. Matthew will talk through some of the earthwork examination process, and Ruth will give a quick talk through the risk management protocols outlined in Civ 86, which is the standards that we apply to. So the first railway in Northern Ireland was constructed in 1839 between Glengall Place in Belfast and Lisburn. The railway network has changed and developed a lot since then, but the earthwork assets that were constructed in the 1800s still form a railway corridor. Northern Ireland Railways own, actively use and maintain over 2,750 earthwork assets, most of which are over 150 years old. Earthwork assets on the network were originally constructed using primitive methods such as end tipping, and a lot of the assets were constructed by hand without much mechanical help. This has left a legacy that we as engineers now have to deal with. Cut and fill construction methods led to embankments constructed of questionable fill material, and earthwork cuttings were excavated to significantly oversteep angles. There have been constant changes to the earthwork assets over the past 150 years. Asset use, track loading, train speeds, and weather conditions have all changed since the original earthwork assets were constructed. Excavation of slope toes has taken place to realign track, reduce curve radius, or install new signalling equipment. Embankments have been raised to improve rail condition, and construction works by third parties at the crest of cuttings and toes of embankments has all contributed to changes in the earthwork asset base. Northern Ireland Railways define an earthwork as an embankment or cutting with a level difference from crest to toe of greater than 3 metres. Northern Ireland Railways are the second largest earthwork asset owner in Northern Ireland, behind DFI roads, and we are responsible for 171 miles of earthworks. Approximately 40% of the Northern Ireland Railways network runs on or in an earthwork asset. There are 2,751 individual earthwork assets within the company's earthworks portfolio, and you can see in the slide a breakdown of the asset types we maintain on the network. We have approximately 90 rock cuttings, and the remainder of our assets are spread pretty evenly between soil cuttings and embankments. Asset types within the portfolio varies. We have large natural soil slopes, like those at Cloughan Point, large man-made soil cuttings in Craigmore Cutting, which leads onto the Craigmore Viaduct at Newry. We have low floating embankments over peat bogs at Adavoyle, natural rock slopes at Downhill, as shown in the image, and man-made rock cuttings within Wellington Cutting, right down near the border. Northern Ireland Railways as a company must deliver a high-performing, safe and reliable public transport system, and we have to do this sustainably. Translink must ensure the safety of passengers and services at the lowest whole life cost and reduce the impact of extreme weather on railway infrastructure. The management of earthwork assets in the railway environment presents unique challenges. Track access is limited due to the operational timetable, and it requires significant planning to view and examine assets. Our network assets cannot be easily and economically replaced, and the age of the assets and limitations of the railway corridor has a significant effect when applying current design codes. There are also uncertainties associated with variable construction materials and methodology used in the construction of the historic embankments. Northern Ireland Railways' annual budget is funded by revenue for maintenance works and capital investment for improvement schemes. Annually, earthworks and drainage spent in the region of £2 million carrying out maintenance works and examinations. Our annual capital expenditure is generally in the region of £5 to £10 million, and listed below is a few of the earthworks and drainage projects we are undertaking at the moment. This list includes the Earthworks and Drainage Resilient project, which you will hear me refer to a lot when I move on to the next few slides, as the core deliverable of this project is to locate, map and condition assess all the drainage assets on the entire railway network. Historically, within the railway environment, drainage assets have been considered a secondary or child asset, there to support the function of the main assets such as earthworks and track. On the Northern Ireland Railways network, just like other major rail operators in the UK, the drainage systems have been historically underfunded, with maintenance and improvements being carried out as a reactionary measure to address flooding incidents, with limited proactive investment. Interventions, when carried out, have historically focused on the failed asset without consideration for the wider drainage system. Recent incidents on rail networks in the UK and Europe have prompted a shift in philosophy to consider drainage assets as a primary asset. As mentioned, we are currently undertaking a project called the Earthworks and Drainage Resilience Project. This project is primarily focused on the collection of drainage data across the entire network. The project commenced in early 2024, and the main focus of the project is to locate, georeference, and examine the current condition of all drainage assets affecting the Northern Ireland Railways network. To facilitate this, we have developed a bespoke drainage app and upgraded our existing Earthworks database to store and retain drainage asset data alongside our existing Earthworks data. Development of the drainage database adjacent to the Earthworks database is in line with Sir Lord Mayor's recommendations following the Carmont incident, and we are one of the first rail operators in the UK to hold this data within one database. The relationship between earthwork assets and drainage assets is considered fundamental to the success of the project. To date, updates to the Earthworks and Drainage database and data collection systems have been completed, and we now have a fully functioning Earthworks app, Drainage app, and integrated Earthworks and Drainage database. Aerial LiDAR surveys of the entire network have recently been carried out and have been incorporated into the database. We have utilised this to identify previously unknown earthworks assets and will be examining these assets during the upcoming earthworks examination season. We have currently covered approximately 22% of the network and identified over 7,000 drainage assets, although this is increasing daily as we have 2 teams out gathering off-track data every day and 2 teams out gathering on-track data every night. A drainage maintenance plan and schedule has been produced based on the information to date, and we have already begun to carry out proactive maintenance activities on poor condition drainage assets in high-risk areas of the network. We are also working to develop drainage renewal and refurbishment plans. As you can see in the image, it takes quite a large team to examine and maintain the earthworks and drainage assets on the network. The organogram on this slide shows the extent of the entire earthworks and drainage team. And as you can see, it involves Translink staff shown in green, supported by 4 separate consultancy firms and 2 contractors. Highlighted in this slide is the earthworks section of the team who carry out the examinations and maintenance works on the earthwork assets. Amey Consultant provide trained earthwork examiners, and Adman Construction provide track safety teams, rail-mounted plant, rope access operatives, and railway qualified personnel to facilitate track access for examinations and to carry out earthworks maintenance activities. We generally have an earthwork maintenance team on track every night from October to February, and our earthworks examinations are carried out during the low vegetation season between November and February. The boxes now identify our drainage team. At the moment, we have 4 separate drainage teams working on the network during both day shift and night shift to gather drainage data. Again, Amey Consultancy provide the trained drainage examiners, and Graham Construction provide the track safety teams and personnel. Translink are also supported by a subject matter expert and 2 drainage engineers from Mott MacDonald, who help to manage the volume of drainage information currently being received from the site teams. For the duration of the ongoing Earthworks and Drainage Resilience project, these teams operate under a project manager in our renewals department, but these teams will migrate to the Earthworks and Drainage team following the conclusion of the project. Translink have competency requirements for members of the Earthworks and Drainage teams who examine our assets. These competencies are based on Northern Ireland Railways Competency Management Framework and current industrial standards. We review the competency of all examiners annually, and our mentoring scheme is utilised to maintain examiner competency. An example of the competency required for an earthwork examiner qualified to examine a rock slope asset is shown on the slide. The requirements for examining rock slopes includes attendance at a week-long rock slope hazard index course in Scotland. Some of our earthworks examiners also hold IRADA rope access certification to facilitate examination of rock slopes while suspended on ropes. I'll now hand over to Matthew, who will talk through the earthworks examination process.
Cheers, David. So just before we touch on the examination process, just explain how we reference the assets uniquely across the network. So the NI railway is split up into 11 sections, and each section has its own unique engineer's line of reference from 1 to 11. And then within each line, it's broken down into miles, half miles, quarter miles. But for our assets, each earthwork is broken down into a 5 chain length, which is approximately 110 yards. And also the side of the earthwork also up or down. So we carry out our examinations in line with CIV 65, and this standard provided by Network Rail sets out the data required to complete an earthwork examination, and also provides the algorithm to calculate the risk that earthwork poses to the railway. And we complete our exams digitally through an app called GizMap, created by JBA. So the first step of an examination is to identify the type of the asset. So that can be a soil cutting, embankment, or rock slope. And typically it takes 10 to 15 minutes to complete an examination, and these are usually carried out from track level. So the first exam we'll have a look at is the soil cutting, and these are probably the most straightforward to carry out, as you have good visibility from track level of most of the features of the earthwork. So initially you'd be looking to capture the max height of the earthwork, the gradient of the slope, whether is there change in gradient from crest to toe as you move down the slope, and other major things you're going to capture existing remediation measures such as soil nailing or toe retention. Also the track offset from the toe of the earthwork. What's also important is to note any sort of movement indicators, either historic or more recent, such as toe slumping or slope erosion. Some of the issues we have in carrying out exams in soil cuttings particularly is the exam requires input of the wider catchment area, and if it slopes away or towards your asset, and this can obviously be difficult to see from track level, so it's best to get a feel for the lay of the land before you're within the cutting. There's also the issue of heavy vegetation on the slopes, which can obscure them, and the examiner has to make the decision, can they see enough of the slope to assess the risk appropriately, or do they require to leave the exam unfinished and come back at a later date once devegetation has occurred. There's also the option to complete the exam with the left heavy vegetated if the examiner feels that it's a low risk asset. And just some other examples of the sort of features we would pick up. You can see there, if the examiner felt they did need to go off track to view the asset better, there still might be restrictions around actually gaining access to crest level just with security fencing. And across the network, there's a number of different types of retaining walls. Here's more of a historic rubble wall, which you usually typically find around the Newry cut, and then a more modern modular block wall. And that example of the modular block, during exam, we would capture that as a construction activity as it's still ongoing. And ideally, you'd want to come back at a later date when the works have been completed to capture the as-built version of the earthwork. Now if we're going to look at the embankment exam, it's quite similar to the cutting in the sense of what you're required to capture to assess the risk. But some of the things that are more tricky with embankment is, as you're typically at track level, you can overestimate the gradient and the height of the earthwork, just given your perspective. There's also requirement to capture any drainage, and most of the sub drainage is signposted around the network, but it's one thing knowing it's there, but getting actual eyes on it to assess the condition is another thing. And again, as with the cuttings, you look at recording any movement indicators such as ballast loss down the slope, or even a lot of the embankments are constructed over, not a lot, but some of the more high risk embankments are constructed over bogs. So you do have an issue with long-term settlement, and on occasion you can see dips in the track, particularly around culverts. Just again, some features that we come across when trying to carry out an embankment exam. You can have flooding at the toe, which then obviously obscures you picking up the height of the slope and the toe geometry, and difficult to assess is that flooding caused by field drainage or no drainage existing. So ideally we'd like to come back to them assets at the dry season to get a feel for what the toe condition is. There's also a lot of the embankments have oversteepened slopes, which obviously poses a risk to the track, but also if the examiner does feel they would like the slope devegetated prior to completing their exam, it does make that more complicated with the maintenance contractor having to make use of rope access specialists to clear a swathe for the examiner to get a feel for the slope geometry. And then just an example of where we have embankments adjacent to water courses, there's obviously the toe scar risk, and again the examiner can't really assess the toe condition of the slope. So the next, and then this is the rock slope examinations. They're quite different from your soil assets, and as David said, you need to do a training course to properly understand what you're required to capture. And the main thing is you're looking at the rock mass characteristics. You're looking at first to capturing your joint sets, your bedding planes, and the spacing between these, along with the compass direction of the slope face. And the software can take this data and make an estimation of the types of potential failures that could occur. But alongside that, you also enter what your opinion is and what any potential failures you can see, be they planar, toppling, wedge, or rattling failures. Alongside that, you would also capture any groundwater flow through the rock face, and in some cases there may be a soil cut above the rock face, and the examiner would have to make the decision: do they feel that needs a separate examination if they feel it poses a risk standalone? And then across the network, a lot of the rock assets do have existing remediation, such as your dentitions, shotcrete, buttress, but the most common is the rock netting systems. And a lot of these have been installed historically, and the information on their design and their as-built condition isn't really there. And the examiner is asked to make an assessment of the effectiveness of the existing remediation, which can be quite difficult when you're not 100% sure on the crest anchor depth or condition. But I'll be going out next week to inspect a rock netting system on ropes that maybe hasn't been looked at for 10, 15 years. So that'll be a good opportunity to see how they're holding up. So alongside the required information to complete an exam, the examiner also records what's known as a risk evaluation matrix. So this sits outside the exam process and allows the examiner to give an opinion, either low, average, or high risk, on different potential failure mechanisms. So you might have, for an embankment, you might have the risk of a translational slip, or is there any detrimental vegetation, or the scar risk, just to give a second opinion, as though the geometry and everything else you're capturing does give a good feel for risk. It doesn't capture everything. There's also room for the examiner just to make general comment on the site condition, and also make recommendation for maybe things that don't directly affect the earthwork asset, but it affecting the overall safety of the railway, such as any structure defects you might see, or animal activity or block drainage, that can be flagged and passed to the relevant parties. And also just generally for the next examiner coming behind you, any hazards that should be noted. So once you complete your exam, the system categorizes that asset within earthwork hazard category, known as EHC, and that ranges from an A to an E, with A being the lowest likelihood of a failure and E the highest. And this directly determines the frequency of that asset for further examinations. But so overall, there's three major classifications of the risk, and that's your EHC, which we spoke about, the risk evaluation matrix, which is the examiner's subjective opinion of the risk, and the overall earthwork asset criticality banding, which looks at the sort of the bigger picture. If a failure was to occur, how many lines it would affect the wider infrastructure, and that's something that Translink are working on currently to get a feel for the overall risk of failure. So just looking at an overview of the assets we examine, there's nearly 3,000 in total, with the majority being embankments. But out of all of them, there's only 6 currently have an EHC score of E, so the highest risk category. But out of the 6 classified as an E, only 1 of those was considered high risk under the risk evaluation matrix system. Whereas you can see EHC is C, which would be considered your medium risk sites. 54 of them, subjectively, the examiner thought there was a high risk element to that asset. So you can't just solely rely on the EHC to predict failure or examination frequency. It needs to be looked at as a bigger picture. So I'll now hand you over to Ruth, and she'll take you through what we do with the examination data and how it feeds into the management.
Thank you. Okay, so Matthew's talked through the exams, and I also undertake exam approvals. These are all carried out in accordance with Civ 65. There's about 800 exams on average carried out annually during the winter months, just due to vegetation dieback. And as Matthew mentioned, the examiners carry out about 8 to 10 a day on average between running trains. It's all done on day shift, and where there are disruptive closures, we try to make use of the examiners on these to make progress. Every year there's a small percentage of incomplete examinations. Some aren't approved, some will require further vegetation clearance and weren't able to be vegetated during the season. They're too obscured for the examiners, or they're inaccessible. A few have also been due to just issues with the software and on the network. I also refer to some of the outputs as, I guess, generic admin outputs, assets that are going to be removed, which are less than 3 meter in height and are low risk. Assets added to the register that weren't previously captured, and David mentioned the LiDAR picking up some of these areas for this year, or amendments to asset types that have been previously recorded. We also have recommendations made by the EEs outside of that risk evaluation matrix. They also have independent commentary that they put in on each asset, and some of those form part of the earthwork maintenance schedule. And there's a few ways that maintenance schedule works is built up, which we'll touch on. We also have the examiners flag high risk assets, which require an earthwork manager review. So at any point, if they come across something which, as Matthew mentioned, is an A EHC but is marked as high risk, we can flag that on the ground by asking for an earthwork manager review. Examiners also pick up, you'll have noticed, independent information on the drainage assets and the structures assets that they encounter. So although Translink are carrying out drainage exams, structural examinations, we can then cross-check that with the independent data collected by the EEs on the ground, because we have to understand that the behaviour of the earthwork asset is dependent on these other assets. So following exams, there's a review of all the outputs. These are scrutinised, and any scores which trigger mandatory drivers for evaluations in accordance with Civ 86, they're listed here on the slide, as well as any non-mandatory drivers are reviewed and agreed with the earthwork manager. The mandatory drivers relate mostly to degradation to or of a D&E asset, or any assets which improve in score, and sometimes safety critical issues irrespective of what that EHC was. So we manage these by either carrying out a site visit, a desk study evaluation, or an online evaluation within GISMAP, and the online evaluation of the day study can be upgraded to a site visit if required. And following this approval and evaluation process, a EEE or the earthwork manager can advise then on manually changing the frequency date if you don't agree with that EHC rating and you want it to be carried out sooner. In alignment then with the risk management protocols that are outlined in CIV 86, Amey collaborated with Translink this year to deliver recommendations grounded in 2 key control strategies. They have interventions and mitigations, and these strategies are sort of categorized into, as I said, deferred intervention management, treated as the mitigations, and refurbishment or renewal interventions. And we also have a standalone referral to other department within Translink that we provide as an output, things that are picked up by the examiners. The interventions are aiming to either enhance the stability of the earthworks through renewal or refurbishment, or to halt any further degradation via maintenance activities. So renewal itself involves substantial works, things that will permanently alter the asset to significantly lower that risk of failure. That could be a full regrade, construction of a major retaining structure, or large-scale support systems, whereas refurb is a lot more targeted. It's localized reprofiling, or it could be adding drainage systems to reduce likelihood of failure. Whereas the mitigations are employed when these interventions aren't yet feasible. They might not be practical, technical, or financial constraints could also be another issue. So these measures, the mitigation, serve as a temporary risk management solution until that full intervention can actually be implemented. But the overall approach is so that we can manage the earthwork portfolio by executing interventions, minimizing that probability of an asset failure, and applying the interim mitigations to lessen that safety impact in the event of a failure. Any exams that don't require mitigation or intervention then are just managed through the routine exams outlined in CIV 65. So as part of the deferred intervention or mitigation, Translink also requests that Amey carry out more frequent visual inspections of their rock slopes and higher risk soil slopes, which sit outside, this is non-standard and sits outside the exam schedule, which I'll explain a wee bit further later. So the recommendations this year came with target timeframes to enable the client, Translink, to sort of plan budget requirements or for proposed maintenance or capital works upcoming. As well as this, Amey also provide emergency on-call consultancy to Translink, which includes the earthwork incident support in accordance with CIV 185. So hopefully that's paints a picture. I know it's a bold slide, but paints a picture of where I'm going with the rest of this presentation. I'm going to cover some of the interim mitigation measures, and then I'll touch on some of the intervention works that we've been involved in with Translink over the last few years. In particular, I'll touch on maintenance, some emergency works, and some refurb renew. So I mentioned the inspections, visual inspections. Prior to Amey joining the maintenance contract, these were paper-based records with local changes on the ground, all on a 2-month frequency. Following the first few rounds of inspection, we digitised all the records. We worked with Translink and JBA to develop a tab within GISMAP so that we could georeference all the photos and the records. And what was important was maintaining the same staff on each section of track to allow them to sort of visually inspect change and to gain familiarity with the assets. So we since recommended alternative frequencies for assets based on findings, and we continue to review the frequency. We add and remove items from the scope where required on agreement with the earthwork manager. The high risk assets are on a 2, 4, 6, 12-month visual inspection, and it's important they sit outside of CIV 65 exam frequency. You'll see me mention one of the renewals at Gora. It's previously was on the list, and since it has been upgraded or there's been a renewal and remediation installed, that'll come off the visual inspection list. But we do, we've worked with Translink to build up every 12 months. We will go visit all of these sites just to build that maintenance schedule. So any debris that needs released from the rock netting, any patch repairs required, any devegetation required, these are built in to the end of the visual inspection schedule each year. So Translink also have an adverse weather risk management plan. There's been 11 named storms back in winter 23-24. Translink had significant issues on the network, especially for that earthwork asset portfolio following Storm Ciarán in particular in October 23. We have been involved in 10 emergency earthwork interventions since October 23, and Translink themselves have an adverse weather plan which cover their vulnerable sites for earthworks. They focus on assets that would be at risk of inundation of surface water, assets that would be vulnerable to scour. You'll see one in the emergency response slide. And this plan is constantly reviewed and updated, and we recommended a number of sites following last year's seasons for addition to the plan this year. In advance of storms, Translink put out speed restrictions where required. They also have a series of on-call teams, their own internal structural engineers, on-call consultants, including ourselves, on-call contractors, and they also have additional track safety squads and plant that they would distribute around the network to be placed on standby. In the past few years, we have had redirection of our own EEs on the network to carry out sort of forensic analysis of any failures, advise short-term temporary measures, and work with the earthwork maintenance contractors to install these short-term measures just to facilitate reopening the route in a safe way, minimizing disruption. It's all about providing safe travel for the end users. As noted earlier, we have 10 emergency earthwork interventions since October 2023, and I've shown them here in bold, the ones that we've been involved in. Most of them were due to rain, some were due to badgers, steep cuttings, unauthorised excavations adjacent to the boundary. I also included on this slide the storm summaries from the last 2 years, just to note that although rain and flooding were features of some of the storms during 24-25 season, it was more so the strong and I guess unexpected winds that caused less of a direct impact on slope stability and flooding in the network, but were detrimental to vegetation across the network. There were multiple trees uprooted, some then caused blocking of drainage at the toe of embankments, causing ponding of water, etc. I'll run through a few of these quickly. So Mullahead on the left there, that was an embankment which was prone to toe erosion and was already being monitored by the client. In late 23 though, due to high water levels and fast flow in the Cusha River at the toe, it experienced accelerated scouring. So ridgeway rock bags were installed to protect the toe from further erosion, maintaining that river channel profile as well. Points Pass in the middle is a site which hosted a major badger set, and the large spoil debris slipped towards track. This one involved an NIEA emergency license to install a king post wall at the toe. And in the design of this one, we included a free length at the top for additional badger spoil. We have found that the badger spoil continues to build up behind this. They didn't move house, and we have to seek license approval under maintenance for clearance of that additional spoil annually, depending on levels. And Whitehead on the far right here was a slope stability issue with rather tight site constraints. It was already an oversteep cut slope. There's ducts at the toe, a narrow cess, boundaries at the crest. Initially, the slip debris was removed and ballast was placed in the slope face as a temporary measure. An alert system was installed by Translink, and the client have since had a long-term solution implemented under a D&B contract. Scarva was another oversteep cutting which failed during November 23, and we had a temporary remediation of the slip area undertaken, another monitor and alert system installed in between until the full intervention was installed with soil nails in 2024. So moving on to maintenance, David mentioned earlier that regular maintenance is carried out annually. There's full-time night shift earthwork squads from September through February each year, and we have sort of moved towards a targeted maintenance program on a 3-year cycle, which has been a great benefit. Some of the typical tasks are outlined here on the slides. I won't go through all of them. But Matthew mentioned there that they are rather rock net inspections. That's some of the guys out at the minute devegetating some of the netting within Wellington 2, and we'll have our EEs going out to inspect that next week. We also agreed methodology under maintenance for in situ investigation of soil cover to aid in that rock slope, soil slope asset identification. You see a lot of the upper soil slope coming down, covering the lower rock outcrop, which is difficult to identify without doing this. It says in the slide there's approximately 15,000 hours of earthworks maintenance track time was accumulated during the 23 season. But maintenance comes with a multitude of constraints: the planning, the length of possessions, the access with the required plant, protecting the track during scaling, debris removal activities. The track always has to be handed back in the morning, so all tasks need to be planned to ensure this within the constrained possession times. As noted previously, when you're referring to refurbishment or renewals, it really is just the difference in scale of the works. There's a few examples of the types here: retention, regrades, protection, reinforcement. I'll quickly talk through a few of the recent interventions we've been involved in before handing back to David. So downhill, following rockfall in 2002, there were 4 rocknet systems installed here. Everyone knows the scene. There were inspections of all 4 netting systems carried out between 22 and 23, and we were then involved in the emergency repairs of components during 2024. And the systems are in a very exposed environment, as you know, and the condition of the netting has been deteriorating. So we've now commenced feasibility and outline design for the replacement of these netting systems. And finally, a draped rocknet system was installed in 2023 in Wellington 2 Cotton, and we put in formalisation of the crest and downslope drainage somewhere in the midpoint of that netting system. And more recently, Gora was another draped rocknet system installed this year. This netting system, however, also incorporated erosion protection matting in areas of significant soil cover. So I'm going to pass back over to David here now, who's going to talk through, I guess, how Translink have been embracing technology and how data collated on permanent earthwork attributes will benefit our earthwork examiners on the ground going forward.
Thanks, Ruth. As you mentioned, there's been a recent push within the railway industry to adopt suitable technologies to reduce the amount of boots on ballast. Earthworks and drainage assets have been no exception to this. Previously mentioned, LiDAR has been incorporated into the Earthworks and Drainage database, and machine learning processes have been utilised to identify unknown earthwork assets throughout the network. We've also captured a number of our rock slope assets using 3D point cloud surveys to monitor the change in condition over time, and we're exploring the use of using satellite monitoring InSAR to monitor a number of our high-risk soil slopes. Remote failure detection systems have been installed on 3 high-risk cuttings throughout the network. We have plans to expand this coverage. The video at the bottom right, I don't know if it plays in this, but shows an alert that we received following a temporary repair. The repair was installed as a rapid reaction during a night shift. The monitoring system was installed, but over the course of the next couple of days, we noticed that there was movement in this. We were alerted to this, and following heavy rainfall, we were alerted to it. We were able to get back out there and improve that repair before the renewal works was done on that asset. We're currently trialing soil moisture monitoring systems throughout the network. We want to better predict when earthwork assets were at risk of failure by understanding the soil moisture deficit characteristics of our cuttings and embankments. That's in trial at the moment. We intend to roll that out further. We have recently installed 12 weather stations throughout the network. These proved very useful in the last few days during Storm Amey. a lot of Translink staff was out and about on Friday night and Saturday, getting lines open again. Further development of our database is also planned. We're currently incorporating earthworks and drainage data within the Translink corporate GIS system to ensure that the earthworks and drainage data that we are capturing is available to the wider business, and all the contractors operating on our network have access to that data. In the last few weeks, we've incorporated geological mapping within the earthworks and drainage database, and are in the final stages of incorporating a new global stability and resilience tool. The GSRA assessment tool examines the theoretical, rotational, and translational failure mechanisms for every soil earthwork on the network and provides us with a better risk categorization for earthwork assets. This will be over and above the EHC, REM, and EACB that Matthew went through that we capture. I've mentioned LiDAR a lot. We're also using it to find drainage channels and concentration features that may exist in areas of the network where we can't access or find them due to vegetation and access restrictions. We've completed one pass of the network so far, and we're working on calibration of the machine learning tools to further expand on this process. So as we move forward, we have significant earthwork interventions planned to improve the safety in the network. Earthwork strengthening phase 1 is underway with a focus on rock slope remediation. As Ruth covered there, the first site in Gora Wood is now complete, and a second site is due to commence shortly. The Earthworks and Drainage Asset Life Extension project is due to commence in a few weeks. This will carry out small-scale refurbishment works on numerous earthworks and drainage assets throughout the network. Earthwork strengthening phase 2 is in the final stages of planning and due to commence in 2026. This project will focus on the renewal of numerous high-risk soil slopes throughout the network. One of the key areas for the future is climate adaptation. We're using weather stations throughout the network for better forecasting, gathering knowledge of our drainage systems, and expanding our remote earthwork and soil moisture monitoring systems. We are also engaging and taking forward recommendations from the Achilles project, which is a UK-wide academic study on the long-term deterioration of linear geotechnical assets by studying the deterioration process, asset performance, and deterioration forecasting, incorporating climate change within that. That's all we have for now. Thanks for listening. We'll play a short video on Translink's climate adaptation plans, and we'll field some questions at the end.
The climate crisis is real, and we're already feeling the impact. Heavy rain, flooding, rising sea levels, extreme temperatures, storms. These weather events are becoming more frequent and more intense. And they don't just disrupt daily life, they put vital transport services at risk. That's why Translink is taking action. We're leading the way in transforming transport across Northern Ireland, strengthening our infrastructure to handle these challenges, keeping journeys safe and reliable, and making sure you're always connected to what matters most. To achieve this, Translink are doing two key things. First, building resilience, getting ready for extreme weather and recovering quickly when it hits. Second, adapting, changing how we work to protect the network for the future. You might not see these changes, but they're happening all around you. Along railway lines, we're removing trees at higher risk from storm damage to keep passengers and staff safe, while replanting in better locations to support biodiversity. Across the network, we're upgrading drainage systems, bridges, buildings, and sea defences to tackle flooding. And we're addressing the challenge of rising temperatures with remote temperature monitoring and mitigations in real time. The call for action is clear. Climate commitments, legislation, and the need for change are shaping the future of transport. Translink is already making a difference, and we're not slowing down. Public transport is the backbone of our economy, communities, and daily lives. But we need focused, sustained investment to reinforce our infrastructure and Translink services. Translink is working with government and industry to build a stronger, more sustainable transport network, keeping Northern Ireland moving and better connected today for tomorrow.